Today we're going to be talking about types of subatomic particles. So before we start, I want to talk about this word subatomic. Let's break this down. So atom, we can clearly see this root word here, but sub, meaning below. So we're thinking below the surface of an atom. So we're thinking about what types of particles are going to be making up atoms. What's smaller than an atom, all right? And we've got three types. We've got protons, we've got neutrons, and we've got electrons. And if we remember correctly, J.J. Thomson was the first person who decided that there were definitely electrons in an atom, and he used the cathode ray experiment to do that. Okay, and then from there we started developing different theories, and this one was got from a guy named James Chadwick, and he determined that there had to be something other than protons inside the nucleus, and so those were your neutrons. All right, so let's learn a little bit about each. First up are our protons, and these are going to be positively charged particles. Okay, so protons have a positive charge, and they're actually having a pretty significant mass. So protons and neutrons have a significant mass, and electrons do not. What we do know is an element is defined by its number of protons. So no two elements will have the same number of protons. So if you have a different number of protons, it means you just have a different element. So an element is defined by the number of protons that it has. Protons are located in the nucleus, which is the center of the atom. And your atomic number is going to be the number of protons, okay? So we define elements by their atomic number, and that's how we organize them on the periodic table, which you'll notice. Right? This is element number 1, number 2, all the way to 118. Okay, so we organize them by their atomic number, which is the number of protons. Neutrons are going to be our neutrally charged particles, so they have no charge. They are neutral. Remember that root, neutral, neutron. All right, they also have a significant mass, and that's going to be equal to that of a proton. So in the center of our atom, we've got protons and we've got neutrons. I draw them sort of like this, like a little group of grapes. Okay? And so that's going to be in the center of our atom, in the nucleus. And what the neutrons do is they help hold the nucleus together. All right? So they help bind these protons all in the same place. We're going to have our electrons floating out here in our different orbitals. All right, we'll get to that next. All right, so next up are our electrons, and our electrons are a negatively charged particle. They have a negative charge. Okay, their mass is incredibly small, and we use this word in science called negligible, which means it's so tiny that it almost doesn't count. So sometimes you see that an electron is referred to as having a mass of 0 because it's so tiny comparatively to the protons and the neutrons that we don't count it. Which is why when we start talking about mass number later, our mass number does not include electrons. It's just your protons and your neutrons. All right? And our electrons are located in orbitals outside the nucleus. And these are actually different distances from the nucleus, and they're also different shapes, which we will learn about a little bit later this year. All right, so the electrons are located outside the nucleus. So now some practical stuff. We need to learn how to write nuclear symbols. So to be able to distinguish different elements with different numbers of neutrons and protons, we're going to use this. All right, so our atomic number is our number of protons, and that goes down here in the bottom. You'll notice that this nuclear symbol is not the same as on your periodic table. Okay, this is something different. All right, so we write our nuclear symbols with our atomic number in the bottom, which is our number of protons, and we put our mass number up here. And our mass number is the number of protons and neutrons. What that is, it's the mass of the nucleus. All right. So this is going to be our number of protons plus neutrons. Okay. the last thing that we do is we need to put our element symbol, which is based on our number of protons. All right, so that will give you some more information. So we're going to try 3 quick practice problems with this. So example 1, we've got number of protons. We look down here, so this will be 6 protons. Number of neutrons, well, we can't find that directly, but what we can do is we know this is our protons plus our neutrons. So our protons is 6, plus n would have to be 12. So our neutrons here are also 6. And electrons in a neutral atom will be equal to the number of protons. So that'll be 6 this time. All right, let's try another one. All right, so this time we've got our number of protons down here, 16. We also could have looked up S on the periodic table, looked for our atomic number, which is 16. Our neutrons will be 31 minus 16, which will give us an answer of 15 neutrons. And our electrons is going to be the same as our protons because we've got a neutral atom. All right, so this is going to be also 16. Last one that we're going to try and do. This time we're giving you information about the protons, neutrons, and electrons, and you need to fill in the information. All right, so here we'll start with our number of protons is 13. So this question mark should be a 13. All right, we've got our number of neutrons is 14. So we know our mass number has to be protons plus neutrons. So that'll be 13 plus 14, right? And that'll be 27. And then in the center here, we have to put our element symbol. That's based off our number of protons. If you look on your periodic table, element number 13 is going to be aluminum. So I put A lowercase l. Right? Here I've made our electrons not the same as our protons. So here we would know this is not a neutral atom. So this would actually have a charge. It would have 13 pluses and 10 minuses. So that would overall be a charge of 3 plus. So that's just a sneak peek into where we are going to be taking this in the next couple days. All right, so what you really need to know how to do is fill out this nuclear symbol based on your protons and neutrons, and then looking at your periodic table based on your protons. All right, nice work.